Hello, everyone. Last time we went over the formation of ionic compound, and from the teach me's that you turn in, some of you were just did one of the elements, not both of the elements. So you really have to do both elements in order for a reaction to happen or a compound to be formed. So let's just review. You have a reaction or a formation of ionic between two elements, potassium and iodine. So let's go over. Potassium is K, iodine is I, and then potassium is found on 1A column, so it has 1 valence electrons, and iodine 7A, so it has 7 valence electrons. Octet. Some of you still not sure about the octet right here. The octet is to gain or lose electrons to get to 8. And it's always the lower number, so you cannot gain 7 or lose, you cannot lose 7, but actually just gain 1 to get to 8. But in this case, it's only 1, so it's easier to just lose the 1 to get to 8. So for potassium, it's easier to lose 1. For iodine, it's easier to gain 1 to get to satisfy the octet. And when you lose 1, it becomes positive. When you gain 1, it becomes negative. And we did the crisscross. Crisscross means the 1 here goes on right here, lower K. So it takes 1 K and 1 iodine to react. All right, let's do one more. Magnesium. Magnesium is in 2A. Oh, the symbol is Mg. Chlorine is Cl. Valence electron is in 2A, so it's 2 valence electrons. Chlorine is 7A, so it's 7 valence electrons, and it's easier to lose the 2 than gain all 6. And in this case, it's easier to gain 1 than lose all 7. So when you lose, it becomes positive, and chlorine becomes negative, and we do the crisscross, so it takes 2 chlorines for every 1 magnesium. Okay. Another practice problem was aluminum and bromine. Aluminum is Al, bromine is Br. Aluminum is in 3A, so it has 3 valence electrons. And bromine is in 7A, so it has 7 valence electrons. It's easier to lose this 3 than gain 5 electrons to get to 8. So it loses 3. Bromine is easier to gain 1 than lose all 7. So when you lose 3, it becomes positive 3. When you gain 1, negative. And then we do the crisscross. It takes 3 bromines for every 1 aluminum. I think we have one more. Cesium and nitrogen. Cesium is in 1A. Nitrogen is in 5A. To satisfy the octet, it's easier to lose 1 than gain all 7 to get to 8. And for nitrogen, it's easier to gain 3 than lose all 5, so it requires less energy. And that's when you lose 1, it becomes positive 1. Then this one is negative 3. Crisscross, it takes 3 cesium for every 1 nitrogen. Okay, one more. Barium and sulfur. Barium is in 2A. Sulfur is in 6A. And it's easier to lose 2. This one gain 2. Now, so this one plus 2, negative 2. We want the simplest when it's Ba2, S2. Now, just like algebra, you have to simplify. So its simplest formula is BAS. Now, this one, you need to pause the video and kind of remember these formulas. This polyatomic compounds. Now, in the polyatomic, some of them, like sulfate, permanganate, you have to familiarize with all these. Ammonium is NH4 plus, and nitrite, different than nitrate. Nitrite is one less oxygen. Hydroxide, OH minus. Cyanide. Now the ones we're going to use a lot are nitrate and not really nitrite, but we use a lot the nitrate, NO3 negative. Acetate is C2H3O2 negative. Carbonate, you need to be familiar with it, CO3 negative 2. Sulfate, one less oxygen. Sulfite is one less oxygen, and it always has negative 2. But let's do some practice. There would be notes up for polyatomic, but for now let's just practice. Sodium. Write the correct formula for the ionic compound composed of the following: sodium and nitrate. Now we know sodium has a 1 valence electron, and it's easier to lose the one, so it becomes positive 1. Nitrate from that table is NO3 negative, and we do the crisscross. Now when we have a polyatomic and we do the crisscross, then the charges on the polyatomic just goes across, and for that one it goes right outside the parentheses. So you always pretend there's parentheses around this, and if this is a 2, for example, then the 2 is going to go outside of the parentheses. But let's see, we'll probably find another example. Calcium chlorate. Calcium is positive 2, and chlorate is negative 1. So the positive, you put a parentheses around the polyatomic, and the positive goes right outside the parentheses. And this is how we got the calcium positive 2. It has 2 valence electrons, and it's easier to lose, and it becomes positive 2. Now the polyatomic, we just got it out of the periodic table. I mean, not the periodic table, the table that we just saw. Aluminum, positive 3. Carbonate is CO3 negative 2. And we do the crisscross, but for the poly we have to put parentheses, and that 3 goes right outside that parentheses. And that's how we got the positive 3 for aluminum. It has 3, easier to lose 3, becomes positive 3. Okay, let's do one more. Chromate, potassium and chromate. Potassium is positive 1, chromate is negative 2, CrO4 negative 2. And we do the crisscross, so we put a parenthesis. There is no need to put parentheses because it's only 1, but the K gets a 2 right here. K2CrO4. And that's how we found K is positive 1, because it's in 1A, so it has 1 valence electron, easier to lose, and it's K plus 1. Okay, so these are extra practice. It's going to be on the notes, but I want to get into something else, naming ionic or reviewing. In ionic, it has a metal, and it has fewer electrons, and it's easier to lose and become positive, and it's called cation. And it's also between a nonmetal, and it has more electrons, easier to gain and become negative, and it's an anion. And it always mentioned last. So metal is first, nonmetal is second. And that's the ionic. So that's just a review. So now to name. First, you name the cation, which is the positive or the metal. Second, you have to use the Roman numeral number for the transition. And then name the anion. It may be ion or just a polyion. and then add the suffix IDE. Salts, it has only two elements. Now AT, you have to pay attention to ATE and ITE compounds. And usually metals. Um, metals are cations and complex anions, usually involving oxygen. I don't know. Let's just see what that means in examples. So let's see. In naming, this is what the rules are. You name the metal first, and that's the cation. And then the anion, which is the nonmetal, it gets the root, and then you add IDE to it. Let's see what that means. It's easier when we see examples. So Na is sodium, Br is bromine. So instead of bromine, it gets IDE. So sodium bromide. So that's how you name ionic. You name the cation first, which is the metal, and then you name the anion by the root of the name, and then instead of INE, you add IDE. Let's get another example. Calcium, you name the metal first. Instead of chlorine, it's chloride, calcium chloride. And then when it's an polyatomic, then you don't have to add the IDE, you just add the polyatomic. Let's see. So for K is potassium, OH is hydroxide, potassium hydroxide. Now this is a transition metal. So that's what we mean by Roman numeral. So, and you get it from this number right here. The transition metal requires Roman numeral number, so 2, because we undo the crisscross. Nitrate, NO3 is nitrate. Copper, 2 nitrate, when it's a transition metal. Let's do one more. This one is also a polyatomic. So silver, now there's no numbers here, or then it has a 1, silver 1, because it's a transition metal. And CrO4 is chromate, silver 1 chromate, or just silver chromate. Okay, I hope that helps. We'll see you guys next time.